In this video, we're going to learn about discounting. Before we get started with Microsoft Excel, it might be worthwhile to stop and take a look at the formulas that we use for discounting. And we're going to start off with the intra-period compounding formula, and that's the formula on the top, the first one you see in front of you. The future value is equal to the present value multiplied by this big gob of intimidating mathematics with the parentheses and exponents and fractions. And I want you to take a look at that big glob of complicated mathematics. And I want you to just imagine that was just one unit, a variable like x. If you were simply to divide both sides of that top formula by x, by that big, massive, complicated, and scary looking math, that would cancel out all of those numbers on the right-hand side, and it would bring those numbers to the bottom of the left-hand side of the formula. And the next formula down displays that, shows that. And I want to show you that so that you understand that there fundamentally is not a big difference in the mathematics of discounting versus the mathematics of compounding. You simply rearrange the formula to answer a slightly different question. The top formula asks the question, if I put $800,000 in the bank at some known interest rate for some known time period, how much money will I have at the end of that time period? Whereas the bottom function reverses that concept. It says, if I have $1 million sitting in the bank at some point in the future, and I have some interest rate in my head that I use as a discount rate, what would that money be worth today? The bottom equation is asking, would I rather have $800,000 today, or would I rather have $1 million 10 years from now? And I'm going to make it a little bit more complicated, and I'm just going to scroll down here and show you one more formula. And what I want you to see is that these two formulas are not fundamentally different in any way. Here, let me add the word value here so that we're consistent. Right? The present value is equal to the future value multiplied by this big gob of math, with one key difference that I left out because I want to point it out to you, and that's a negative sign here. This is because if you divide by an exponent, a number that has that's been raised to some exponent, that is the mathematical equivalent of multiplying by that same number raised to a negative exponent. So 1 divided by x is the same thing as 1 multiplied by negative x. And so this bottom formula you sometimes may see in a textbook, you may see it online, and these two formulas on the screen in front of you are equivalent. They've just been slightly rearranged a little bit because, you know, if you have 1 divided by x, that's the same thing as 1 multiplied by x raised to the negative 1. So raising to a negative exponent and dividing by a fraction with an exponent in it are the same operation mathematically. And I want to make sure you saw that, simply because guess what? Sometimes when you're typing numbers into Excel and trying to enter formulas into Microsoft Excel, that bottom equation is a whole lot easier to enter in, simply because it's easier to keep track of everything as you're doing it. And if you're just punching this into a scientific calculator, not using a finance calculator, that bottom fraction is actually easier to work with, because typing a negative sign is infinitely easier than dividing when you're entering these things in. So these are the formulas. And what I want to do now is I want to jump into Microsoft Excel and demonstrate to you how discounting works, how to enter an equation that can do discounting for you in Microsoft Excel. So I'm going to hit the stop button and switch over to Microsoft Excel, and I'll see you in Excel in just a moment. So here we are in Microsoft Excel, and off camera I went ahead and started laying out my spreadsheet. If you want to follow along, you can just hit pause and type in what you see here on the screen. In a previous video, I put together a spreadsheet that demonstrated how to calculate the future value, and all I've done is taken that exact same spreadsheet and tweaked it a little bit for the purposes here because I didn't want to type everything in again. So here is the question I have for you. Let's imagine that 10 years from now, someone promises to give you $1 million. I'm just going to cut you a check for $1 million in 10 years. So there we go. And my question to you is, would you rather have $1 million 10 years from now, or would you rather have $800,000 right now, today? And well, in order to answer that question, we need a discount rate, and we need to decide how often we want to compound. And we would like to plug in some math to see what $1 million 10 years from now would be worth today. In other words, $1 million in the future is worth blank today. And we're going to figure that out. For our discount rate, we're going to leave it at the same 12% we used in a previous example. The discount rate is a very complicated thing, and picking one is equally complicated. We'll set that aside for later, and I'll set up a video to kind of talk through the psychology of what a discount rate is. We're going to do 10 years. We're going to do monthly compounding just because, for no other reason, because that's the number I happen to have already typed here. And you can arbitrarily pick a number of years or a discount rate or the number of compoundings in a given year just as easily as I can. And those things will change the results. So what I want to do is enter a formula for the present value. So the present value is equal to the future value multiplied by, open parentheses, 1 plus our interest rate divided by the number of compounding periods, the periods per year, in this case 12. So I click on the 12, and then we close that parenthesis. And again, I always like to go in and add a few extra parentheses just to make sure the order of operations is going to behave the way I intend it to, because I'm always expecting Excel to not interpret what I've typed the way I want it to. That's just my default, and it should be yours as well, because then you're always going to be a little bit suspicious and take a look at the numbers you're getting and double check them and make sure you've got the right number. Going to hit Shift and hit the 6 key. That'll give us a caret. Going to do an open parentheses. And now this is important, and this is the thing that distinguishes the present value calculation from the future value calculation. I'm going to type a negative sign. And then I'm going to click on my periods per year, number of times I'm going to compound K in the formula I showed you earlier, multiplied by the number of years, which is usually N, and of course different textbooks will have different formulas for that. I'll close that parentheses and I'll hit enter. And what I find is I get $302,000. That means that I would definitely prefer $800,000 today. This is the equivalent of saying that $303,000 is the same thing as $1 million 10 years from now with our given discount rate. Now, how do we do that in Microsoft Excel with an Excel function? We type an equal sign, and the function we're looking for is PV, for present value. It kind of makes sense. It's just an abbreviation. So it's always, if you're just guessing, you can just abbreviate what you're looking for. We'll do an open parentheses, and now we're given the same prompts that the future value function gave us as we've seen before. So we have a rate, right? So that's going to be our discount rate, our 12% discount rate. But remember, we're doing intra-period discounting, so we're going to divide by the number of periods in a year, 12. Now I'll type a comma. Now we need the number of periods, so that's going to be 10 years, an asterisk to multiply by the 12 compounding periods in that year. And then a comma. Now the payment function is what you would use if you were calculating what we call an annuity. This is where you have a stream of payments every single month. We don't have that in this case, so we're just going to type a 0 here and then type a comma. And now we click on the future value function, or now the next argument is future value. So we're going to click on that $1 million future value that we're interested in, and we're going to simply close the parentheses, and we're going to see what happens. Well, that's great. We get the same number, but it's red and it has parentheses around it. That indicates a negative number. That's a very standard accounting formatting. When you see a red number in Microsoft Excel, it's a negative. Well, why is it negative? Really simple, because these things are based on cash flows, right? These are based on cash flows. So what you have to do is just kind of go into your formula. I'll double click to edit the formula, and you can put a negative sign in front of the D3. Alternatively, you could probably put a negative sign here in front of the PV. It shouldn't make any big difference. I'll put my negative sign in front of the D3, which points to my $1 million future value, and I press enter. And there we go. $302,994 is worth the same thing as $1 million 10 years from now with this discount rate. And that is the basics of how you would use Microsoft Excel to calculate the present value of some future sum of money. If you know of a more efficient or more effective way to calculate the present value in Microsoft Excel, I'd love to hear about it in the comments below. This channel is all about learning, and we can learn by communicating with each other and sharing knowledge in the comments. I would appreciate a lot if you would like my videos and subscribe, and I hope that you will stay tuned for the next video where I'm going to spend a little bit of time talking about the discount rate and how that impacts the final result we get in these examples. Thank you.